So, we discussed that Galilean transformation cannot be the right kind of transformation for our nature, for our world, because that second postulate, the constancy of speed of light in vacuum, that cannot come out from Galilean transformation. And the second postulate has come from the experiment. So, we believe that. So, the Galilean transformation has to be modified to take care of these two postulates. Then together with homogeneity of space, homogeneity of time, isotropy of space, we started writing equations and we reached to a stage where x prime was some constant times x minus v t and t prime was some d x plus f t. So, we have now three unknowns and of course, we had taken y prime is equal to y and z prime is equal to z. So, we have three constants a, d and f. These are three constants and therefore, we need three equations, and to get those three equations, what we are considering is, suppose we have this frame S, origin O, and then frame S prime which is just crossing this F, origins crossing. So, this is S prime frame, this is S prime frame and origin is just at the same place, O and O prime are at the same place, just crossing. And at the crossing, some electromagnetic radiation pulse, very short pulse is generated and that spreads in all directions. So, during this origin crossing at that instant, not during, at that instant, EM wave is generated, EM radiation is generated and then it goes this side, this side, this side, all sides. In this context, we will be taking three events. So, the first event is that as seen from S, time t has elapsed and the pulse or the leading edge of the pulse on the x axis has reached the point x is equal to c t, because that is electromagnetic radiation or light moves in all frames with a speed c. So, this light which is emitted has reached somewhere here and that is time, this is from S, time is t and x is c t. My radiation pulse has reached this point, what time? At time t, where origin and then it has reached here. So, the distance covered must be c t. So, x is c into t. So, this is it. Now, if I transform the same event to S prime frame, this is our event. When we say this is the coordinate and this is the time, we are giving event. So, y is 0, z is 0. So, this gives where and this gives when. So, that is the event. Now, if the same event is seen from S prime, what will happen? From S prime, use transformation equations here. From S prime also, this particular event is on the x axis, because x axis and x prime axis, they are all same, both of them are on the same line. So, this event has taken place on the x prime axis, y prime is 0, z prime is 0 and it is here. So, what is x prime? X prime is equal to a times x minus v t, that is a times x is Ct. So, this is Ct, then minus Vt, that is it. And what is T prime? In S prime frame, when did it occur? T prime. So, T prime is given by this equation. So, d into x plus f into t, that is d into x is Ct. So, it is C into T and then plus f into t, and of course, y prime and z prime are 0. The event is on the x prime axis, and even otherwise y is equal to y prime, z is equal to z prime. So, it is this. How much is the distance covered by this light pulse in S prime? The distance covered is x prime, because in S prime also it was generated at the origin, and then at T prime at this time it is at x prime and it is on the x axis, that radiation, that pulse, the leading edge of the pulse, and hence if you divide this x prime by this T prime, that must be C. So, x prime must be equal to, or x prime by T prime, this should be C. X prime by T prime should be C, or x prime should be C into T prime. X prime should be C into T prime. Divide here. What do you get? A into this, A into C minus V. When you divide, this T is going to cancel out, this T here, this T here, this T here, this T here. So, in numerator you have A into C minus V, and in denominator you have dC plus F, dC plus F. So, that is x prime by T prime, that must be C. So, this should be equal to C. X prime by T prime is equal to this much, and that must be equal to C, and therefore, A into C minus V is equal to dC square and plus Fc. So, we have gotten one equation in these three quantities A, D and F. That is, these are the constants coming A, D and F. So, we have gotten one equation. We considered one event and we got one equation. Now, consider another event, and this event is that we have pulse is also going, this radiation is also going in the negative x direction. So, as seen from S, the pulse has reached this point here, which is x is equal to minus Ct. The pulse has reached here at time t. Okay. So, let us write that event 2, this is event 1. Let us write event 2, and from S, first let me write it from S. From S, time is t and x is minus Ct, and y is 0 and z is 0. So, I am looking at the radiation that is going along negative x axis, and at time t it has reached this point, x is equal to minus Ct. This is the event. So, time is here and location is here. So, this is the event. Now, this event, the light is going and reaching that point at time t. This particular event, as seen from S prime, what will happen? So, you can write from S prime. From S prime, let us write this x. So, x prime is equal to A into x minus Vt, and what is x? X is minus Ct minus Vt. that is x prime minus a and c plus v. And what is t prime? T prime is equal to dx plus ft, dx and plus ft. X is minus ct, x is minus ct, so it is minus d c t and plus ft. And if I divide x prime by t prime, what should I get? X prime by t prime, I should get minus c, right. X prime is the x prime coordinate of this event and t prime is the time. So, x prime is minus c t prime. So, x prime by t prime is minus c. So, you divide here, what do you get? Minus c equal to x prime divided by t prime. So, you divide, this t is also here. So, when you divide, this t gets cancelled and you have minus a, then c plus v here, then divided by this t cancels out. So, minus dc and plus f. So, minus c, x prime divided by t prime is minus c. So, either minus c, this side this is minus a c plus v t. So, this minus a c plus v t and then divided by this minus d c t plus f t, t cancels out and it becomes this. So, let us work out little bit. You can remove this minus and this minus and then let us cross multiply minus d c square. So, minus d c square, this is minus d c square and then plus f c. So, plus f c is equal to this side a into c plus v. Now, look at this equation and this equation. Let me write this equation again there. So, d c square and plus f c is equal to a c minus v. This was my second equation, this is my first equation. First equation I am rewriting. So, d c square plus f c, d c square plus f c is equal to a into c minus v. So, a into c minus v. Now, you add these two. You add these two, this minus d c square cancels with this plus d c square, f c plus f c will be 2 times f c and that is equal to this a v and minus a v will cancel out and a c plus a c will be 2 times a c. The 2 also cancels out, c also cancels out and you get a is equal to f. From these two equations you get a equal to f. I need one more equation and therefore one more event. So, let us try that. And the third event is from S, looking from S, the radiation which goes in y direction, pick up that, a radiation that goes along y axis and at time t reaches the point with x coordinate 0, y coordinate ct and z coordinate 0. So, that is the event. So, radiation is going along y axis. So, at time is t and the location is x is equal to 0, it is going along y axis. Then y is equal to ct. In t time the radiation will travel this distance ct. So, along y axis it is travelling a distance ct. So, the y coordinate is ct, z coordinate is 0. That is the event. And this event, radiation which is going along the y axis in S and reaching a particular point of the y axis at time t. These are the coordinates and this is the time. This event as seen from S prime. So, from S prime, this is my event number 3. So, this is our event number 3. Event 1 was light going along the positive x axis and reaching the distance c t here on the x axis. Event 2 was light going in the negative x direction and then reaching here, and event 3 is that light going along y axis and reaching here. So, x prime is equal to a into x minus v t, and x is 0. So, I will put 0 here, and therefore, x prime will be minus a v t, that is x prime. Y prime is equal to y prime is equal to y, and y is c t. So, y prime is equal to c into t, and of course, z prime is 0. So, in S prime, what is the distance travelled by this pulse, by this radiation after emission? Emission was at the origin O prime. From there it started, and now it has reached a point x prime comma y prime comma z prime at time t prime. So, what is that distance? X prime is here, y prime is here, and z prime is here. So, the distance travelled by this pulse from S prime, remember I am talking from S prime, the distance travelled by the pulse will be, if I call this distance d, capital D, distance will be x prime square plus y prime square plus z prime square and square root of that. Okay, because it originated at the origin O prime and then it is reaching x prime, y prime, z prime. So, this is the distance covered, and time, okay, time I have not written, time, and time at t prime equal to 0 it originated, remember. So, time t prime is given by d into x plus f t, and x is 0, so it is f t. T prime is dx plus f t, and for this event x is equal to 0. So, I put x is equal to 0. So, t prime is f t. So, distance by time is the speed of that light in S prime. So, that should be c. So, d by t prime, that should be c, and that should be square root of, what is x prime? What is x prime? X prime is here minus a v t. So, x prime square, a square, v square, t square. So, this is a square, v square, t square. What is y prime square? What is y prime? Y prime is c t. So, y prime square is c square t square. So, plus c square t square, and z prime is 0, and that divided by t prime, and t prime is f into t. This is it. So, t cancels out, this t here, this t here, this t here, that cancels out, and you have f into c is equal to square root of this. So, square it, you have f square c square, f square c square is equal to a square v square and plus c square. This is our equation number 3. So, we had 3 unknowns, we have 3 equations, we have also partially solved the first and second equation, and from there we have gotten A is equal to F. So, I can use it here, A is equal to F. So, in place of F I can write A. So, it is A square C square is equal to A square V square and plus C square, and take this on the left, A square common, C square minus V square, and that is equal to C square. So, A square is equal to C square divided by C square minus V square, and that is 1 divided by 1 minus V square by C square. So, it tells me A is equal to square root of 1 by 1 minus V square by C square, and that same is the expression for F also, because A is equal to F. Okay. So, I get A same as F, and that is 1 by square root of 1 minus V square by C square. And then you need D. So, any of these 2 equations you pick up for D, because now we know what is A, now we know what is F. So, we can write D from any of these equations, or I can subtract this into this. So, if I subtract this second equation from the first equation, what do I get? I get 2 times dc square, dc square and minus dc square, this cancels out, and here we are subtracting. So, AC and this AC cancels out, and minus AB and minus AB is minus 2 times AB, and hence D is equal to minus AV by C square. So, D is equal to minus V by C square, and then A, and A is here 1 by square root of 1 minus V square by C square. So, I have all the 3 things with us, D is here and A and F are here. So, we are ready to write the Lorentz transform equation in its final form, and that is, start from here once again, x prime equal to A, I know what is A, x minus Vt and divided by square root of 1 minus V square by C square, that is x prime. A is 1 by square root 1 minus V square by C square, y prime is y, and z prime is z, and t prime is d into x, and what is d? Here is d, d into x, and plus f into t, and f and a are same. So, f into t, let us write f into t. So, f is 1 by square root 1 minus V square by C square and into t. So, this is this part f into t, this is f and into t, and then plus d into x. What is d? D is here, and d into x. So, d into x will be minus V into x by C square, and then this factor. So, this factor is same as we had written there in the denominator. So, it is minus V x by C square, and in denominator this. So, minus V x by C square and this denominator. These are Lorentz transformation. Which will take place of Galilean transformation. If you want inverse transformation, if x prime, y prime, z prime, t prime are known, and I want to write x, y, z, t in terms of these x prime, y prime, z prime, t prime, I can use principle of relativity. S and S prime have same status. S prime is going along x axis with respect to S with a velocity plus v, and S is going along that x axis once again with a velocity minus v along the positive x axis. It is going along the negative x axis. So, you can write it is velocity minus v in positive x axis. So, all you have to do is replace v by minus v and primed things by unprimed things and vice versa and finish. So, that inverse transformation will be, if I do it here, x prime, so write x here equal to, the denominator remains the same, 1 minus v square by c square. When you put v minus v in place of v, this does not change. When you put minus v in place of this v, this will become plus. So, it is x prime and plus v t prime. Of course, I can do algebra and get it from here, from all these equations I can get it, but simple to use principle of relativity. Y prime is equal to y will become y equal to y prime, z prime equal to z will become z is equal to z prime, and here once again t prime. So, t here you have that same factor 1 minus v square by c square, and then t prime here, in place of t you write t prime, and minus v will become plus v. So, plus v into x will become x prime and by c square. So, these are inverse transformations. If you have x prime, y prime, z prime, t prime and you need x, y, z, t, then you can use these equations. Now, there are some symbols frequently used, two symbols I will introduce and I will also be using them often. One is this v by c is written as beta. Many times v by c is written as beta, and 1 by square root of 1 minus v square by c square, this factor, this is written as gamma. So, these symbols we will also use frequently, and in terms of this you can write x prime is equal to gamma times x minus v t, and y prime is equal to y, z prime is equal to z, and t prime is equal to gamma times t minus v x by c square. So, these are the kind of symbols people often use. Now, the question is, are Newton's laws invariant under Lorentz transformation? If you work out, you will find that accelerations are not same in the frames S and S prime. If you have a particle having some acceleration a as measured from S, not necessarily, or in fact it is not that the acceleration of the particle will be a in S prime also, and Newton's law F equal to ma is not invariant under Lorentz transformation. So, what we have to do with Newton's law, we will take it up later in the course. First, we will do some kinematic derivations from these equations. These are new equations, new types of equations. So, what do these equations tell about the lengths and time intervals? Those things we will be taking up after this.